Thanks, Mike. We as speakers all drew straws to see who got to follow Mike King, and unfortunately I didn't win. But I'm excited to speak with you guys today about developing automated SEO tools and share some of the things that we've learned recently about search in the age of large language models. So as you've probably heard from a number of speakers today, search kind of really changed with the launch of ChatGPT. Everything's a little bit different for us now. When we think about that, what has changed for SEOs? What's different for us today than it was previously? Well, it's becoming more and more clear that search engines are going through the process of changing from search to becoming answer engines. That's really what their goal is. They want to provide the answers for people so that they don't have to go look for them. We're seeing this not just with Google, we're seeing it with Copilot, ChatGPT, others that are entering this space. They are very particularly interested in being able to provide you with the answer you're looking for exactly when you need it, instead of having you have to take the effort to go search for it. But an interesting thing that you've seen from Mike and others that are talking about it is that with the release of ChatGPT, we suddenly had competition for the first time in this sphere, competition to become the answer engine. And so that also led to the increase of access to tools that power these search engines. So we have Google Vertex AI that Mike King referenced, providing details and access to APIs related to text embeddings, these vector databases, OpenAI, Copilot, Gemini, open source language models, lots of other areas. And we've also heard speakers today talk about Google's cloud library being increasingly accessible for things like natural language processing APIs and tools and references to us. So one of the other benefits that we have from all of this is that costs have decreased significantly. In some examples, they've decreased 99.9%. This is actually the cost for Google's natural language processing API from March 2023. You can see on the left, it was $1 for every 1,000 characters that you processed, and now it's 0.001 cent per every 1,000 characters you process. So significantly reducing the cost to allow us to do things with these tools that we probably just couldn't afford to do at scale previously. With all of these tools that have become available, one of the things that I like to do as I'm learning things is to actually build with them. I am not a developer by trade. I am a technical SEO by trade, like many of you. But I like to jump into things to really understand them, because then I think you can make better decisions, better recommendations, and get a search from how that does. So I'm going to share a little bit about what I built to help me understand all these technologies and how they work together. One of the things that we were having is we have language models that are really powerful that can do lots of things. We have voice models that can do things like clone voices and replicate things. We also have these vector embeddings that basically allow us to have semantic search capability that we never had previously, which is an extremely powerful tool to get to information. So I like to build projects not just related to SEO to learn things, but other areas, and I'd encourage you to do the same. And one of the things that I started to do to learn these technologies is I had access to my grandfather's journals. And I said, hey, this is a corpus of documents. It's similar to search. What if I could take this corpus of documents and I could vectorize them and embed them and stick them into a vector embedding database? And then with that vector embedding database, what if I could then tell a language model that it was my grandfather? And what if I told my grandfather's language model that it had access to a collection of memories? And those collection of memories were its journal entries, right? And then what if I had a recording of my grandfather and I was able to take and clone his voice? My grandfather died in 1989. He was a World War II vet, and I put all of this together, all these technologies, to see what would happen, and we created ChatGPT with Grandpa Hink. And so,
joined the Army in part because of a shady story and deal about a motorboat, and because my cousin was leaving for the Marines. Getting my mother's signature for enlistment was the hardest part. but I managed to convince her. After finishing school, I enlisted and left for the war on June 30th, 1942.
So all of these technologies are pretty crazy and incredible. For me, I was able to hear my grandfather again and ask him questions and get answers that were based on his real life in his own words and with his own voice. It's an incredible, powerful technology. But through it all, it helped me understand also the technologies that we can use in my day-to-day life with my job. These language models, they've lowered costs, the tools are more accessible, they're easier to access, and because of that, we can create powerful automated SEO tools. So I'm going to talk a little bit about, well, what are some of the things that would limit us from being able to be successful with these tools? So large language models, they've got weaknesses. One of the things that we often hear is they're bad at math, they hallucinate, they have limited memory, although that's becoming less and less of a problem. Definitely was when we were first starting this process with these tools. And so when we at Go Fish, we were thinking about all these things, we started to think, well, these language models, they're used by search engines, and they must have figured out a way to get past these if they're going to deploy it into their search product, right? Like there has to be a way for us. So we started to wonder, well, what can we do as SEO to solve these same type of problems, to be confident enough that we could automate these things at scale? How can we use these at scale with confidence that they're not going to give us bad data, hallucinate, make things up, or run out of memory? So one of the first things we saw was just related to math, right? Like, hey, don't use large language models for title tags or meta descriptions, small, simple things that we have to do all the time. They can't count characters, they make things up. But we started to think about it too, and we said, you know, I'm an SEO, and if you asked me to create 100 title tags without using a tool to determine how many characters I had used, and if I met that threshold of 60, if I was going to be over or under it, I would probably fail. I wouldn't do that well at it. In a language model on its own, it fails about 60% of the time. But we learned that if you gave language models tools to check their work, they did a pretty good job of that. So what we did is ChatGPT and other language models have the ability to call functions. Functions can be things like calculators. They can be tools that work for you. And so we gave language model through functions the ability to do things like check character length. An interesting thing happened is that when we first started this, we just returned back to them the characters, like 35, 65. And the language models didn't quite know what to do with that. And so we have a tip that is if you actually return information the way that language models work best with instructions, they do significantly better. So our function returns things like, title tag is too long with 65 characters, please write a shorter one. And when we made that change, we saw that language models' ability to check their own work reduced their error rates in terms of character count from 60% to 1%. So a significant improvement that we could solve and be confident that we could build automated tools on and scale. Moving to the next topic, language models can't be trusted. They hallucinate and make things up. This one was a fun challenge to solve, and there's a few things that we found out is that like if you actually give language models the ability to say I don't know, they'll use it, right? Like that's one of the things. They're statistically predicting what the best answer is, and if they don't know the answer, often the statistical best prediction is I don't know if you give them that access. And the other thing is that you'll hear people with retrieval augmented generation, RAG, the ability to grab answers and include it in prompts. If you give the answers based on retrieving information from vector databases or other sources, that language models do a pretty good job of not hallucinating or making things up. So wanted to just show you an example of how this might work. So you have an example, a user prompt to a language model might be something like, did the Dallas Cowboys win the Super Bowl? What we could do programmatically to make sure a language model didn't hallucinate would be to send it something like this. Did the Dallas Cowboys win the Super Bowl? Use the data below to answer the question. If there is no answer in the data, reply with, I don't know. And then you inject the data that you've gathered from some other source. In this case, you know, this example, the Dallas Cowboys did not go to the Super Bowl. Sorry, Dallas Cowboy fans. And what a response would be something like this is the Dallas Cowboys did not win the Super Bowl. If the data didn't include that information with this prompt that we just showed here, it would actually reply with, I don't know, because That's the statistically most relevant answer based on the prompt that you had sent it. So how do we, as technical SEOs, include answers to all of the possible questions for queries in the prompt? Like, there's infinite possibilities with data when we're working across wide ranges of websites and other areas. And how do we then solve that limited memory problem? So one of the things that we talked about when I showed that demo of my grandfather is that we need to actually act more like search engines now. We need to gather information through things like APIs, scraping content, natural language processing tools. We need to organize it, similar to what a search engine does with databases. And then we may need to retrieve it through code to include into language model prompts when it's needed most. So in other words, we need to do exactly what search engines do every day. They crawl data, organize it in a database, and retrieve the information and present it to a user when they need it most. So how can we get answers for SEO? One of those things we're going to talk about, and Mike went into a lot of detail, and I'll go through quickly, is Google's Vertex AI, text embeddings, or other embedding models. My language of choice is Python, but you can use JavaScript or any type of other area to help receive information. And then one of the things we need is API access. We use SERP API a lot because it gets us quick, clean data information structured for seeing what's happening in the search results for a specific time when we're running and doing automated information queries. So just real quickly, Mike went into a lot of detail, but this text embedding model is a process of taking text, moving it into a model, getting a numeric representation of the meaning of that text that lives in that vector space that we've heard about today. Just the quick summary, things that are similar to each other are going to be more closely related and located to each other. And then we can identify and understand the similarity of topics or grab answers that are most related to the topics we're talking about by measuring cosine similarity, the things that are closest to each other. So vector embeddings, cosine similarities is a crucial tool for us for building automated SEO tools moving forward. It's something where if you don't learn about it, if you don't know much about it today, that's the homework. Go home, understand this concept. It's going to change everything that you do moving forward, and it's going to allow us to pass questions with answers to large language models so that they can be accurate. One of the things that we saw when we started working with vector embeddings and language models is that we see Google using similarity scores all of the time. It's most likely the way that they rewrite meta descriptions. I'm going to show 3 meta descriptions for the same page that change based on the query entered. So in this example, you can see is like, how is an IP address assigned? The meta description answers that question, right? It's assigned by an ISP. That same page, but with a slightly different query. What is an IP address? And an IP address is a unique numerical identifier, right? So the only thing that changed was the meta description in the query. The page didn't change. And then a third version, like how many versions of IP addresses are there? And there are 2 versions of IP addresses, right? So Google is able to identify the text on your site that is most semantically similar to the query and has identified that they get better click-through or engagement data if they include that as the meta description. So if you're frustrated with your meta descriptions not being used, it means that they're not relevant to the queries that they're being asked. They're not semantically relevant to them. So we thought at GoFish, like, hey, what if we could do this same thing? What if we could look at content in a similar way to what Google does? And so we decided to build a Chrome extension that does a lot of this, and it's in private beta. If you guys are interested in it, send me a message on LinkedIn and we can have a conversation. But we're going to be releasing this soon. Essentially, it's taking all the text on your site, passing that to Google's Vertex text embedding model, receiving that information back, measuring the distance between the target keyword, and then updating the DOM with the score and a heat map. So this similarity score essentially is this: you enter target keyword, you hit go, processes all the content in your site, and then overlays that on the page so that you can see exactly what parts of the text on your site are semantically scoring well and which are not. It can help you identify what areas of the site potentially need content updates. And then we also generate a page similarity score. Our belief is that this is similar to the content warehouse database, content warehouse leak. In the way that we were reading the instructions is that Google is probably taking an average of all of the nodes on the page in creating an average embedding from them to generate a page similarity, a page score. And then they do the same thing at scale to get your site score. So these new tools at affordable prices allow us to automate information gathering and content scoring to provide better SEO recommendations. It's a groundbreaking initial process for us. But what are some examples of ways that we can actually automate SEO? How can we make this go faster for us? So some of the examples that we have used and built, and one of these is like we can review the search result page pretty quickly, identify search intent and content freshness. We can do that through language models like Search API, OpenAI, and then from APIs like SERP API. Ahrefs recently introduced this feature into their just data set, but doing a similar process to what you can do manually. Other areas that we can do it is we can identify helpful content gaps from competing sites by leveraging large language models. So you can use Python, scrape content from a number of different sites, pass that organized content over to language models. A pro tip, if you're trying to compare data for language models, the best way to do that I found is JSON. Structuring the information in JSON and passing it to language models works similar to what we would see in like a table. Language models like JSON, it's really easy for them to understand. You can discover information gain opportunities. Mike talked a little bit about this. One of the ways to do it is if you pass the content from a collection of corpus of documents, and then you compare them all against each other, you can identify what are the common facts on all of these pages, which ones are the unique facts, and then what's missing from your site or your client site. And it can do that all at scale and quickly through the combination of language models and Python content scraping. You can review content on a page to see if it's answering the people also ask question. APIs like SERP API can get you that detail and information, pass that through a language model and ask, is it answering these questions on your client's page? If it's not, let us know. In this example, we can see that we show both the search answer, was it answered by a client, and then what the client's answer was. So you can compare like, how is this answer different than the answer that Google has suggested as the best answer for that particular question. And then also the red items would identify that this content didn't answer that people also asked question. You can create these vector embeddings and generate similarity scores for clients and competing pages. So similar to that Chrome extension, you can build it into automated tools to grab that content, score it at the node level, the HTML tag level, so you can see what parts of your content is scoring lowly. One of the great benefits our team uses this for is we can actually make recommended changes and see what the changes would do to the similarity score before we publish it live. So you can click, make updates to the text, rescore the content and see, is this moving in the right direction or is it going to hurt our content before we publish it? You can also do what Mike was talking about with if you then create a page embedding for every single page on a site, you can then get your site authority score, the page scores, and you can then compare it against multiple competitors. And so you can see versus target keywords. It's hard to see a little bit, but the green dots down at the bottom versus 2 sites that are competing for those queries. We can see the orange site has a lot more information, a lot more topical authority, even though they're not as closely related to the target keywords. Help us make content decisions based on that. You can do things really simple like, hey, let's just grab all the images on a page in the alt text and the file names and see which ones are missing, which ones are doing, so we can quickly make recommendations at scale. And we can use the correct tools for the correct purposes, right? So if we're trying to understand entities, we can use Google's natural language processing entity. We can grab that from multiple pages and compare them against each other. So we can see which ones are missing from particular pages at scale, then make recommendations on what to do to the content to integrate those entities that we're missing. And we can even do things like make a good guess at topical authority. One way to do that is to use a search API to get search results for each of the sites by doing a site query plus the keyword. That's going to give you a good idea of the number of pages that are returning for our particular topic. If you then compare the content of each of those pages with semantic similarity in their page embeddings, you can then see which ones are most relevant to that content, and you can identify if there's gap in your content for a topical authority that you're trying to rank for. In this example for SEO for construction companies, GoFish Digital needs to write some more articles so that we can be a little bit more of a subject matter expert on that area. One of the other things is you can use all these tools to identify internal linking opportunities through an automated process and at scale. Again, you're looking at all of the number of pages, you find the paragraphs on those pages that are the most semantically similar to a particular keyword, getting semantic scoring, and then that returns to the document so you can see like, hey, we're not linking on these pages, but we should because we have paragraphs that talk about these topics throughout the site, and we can grab that information. So, and there's so much more that you can create, right? We've heard lots of people today and yesterday talk about all of these new technologies, the different ways that you would use them for your particular industries. The reality is it's endless. And I showed that example at the beginning of my grandfather's is that like, it's something that you can do. These tools are incredibly easy to use now versus years ago. In addition to that, we have these large language models that can help us build things. So that's one thing I just want to make sure everyone is confident that they can go and do that. So all those screenshots you saw come from a tool that we use internally that we call Barracuda. It's essentially the process of going out, gathering information about a particular client's web page and the competing pages, aggregating it back together. Typically that process before we automated a lot of those steps took about 4 hours. It was gathering information, pulling it together, and then we'd make recommendations. Barracuda now goes and gathers all of that same information to allow our SEO teams to use that information to then make recommendations. And it gathers all that in about 4 minutes. So, you know, the time saved by just being able to go automate these tasks, use these tools and technologies can be a significant advantage for you in terms of what you're doing. So in conclusion, just want to make sure that everyone understands this. There's so many tools that that are available to us to help us do what we do. And accessing these tools is cheaper and easier than they've ever been. And that we can use these tools to automate information gathering, scoring content, and allowing us to make recommendations that make an impact. Thank you.